A single launch could place an entirely new space station into orbit. Designed with nearly 400 cubic meters of pressurized living and working space, Starlab brings together advanced research laboratories, robotic systems, artificial intelligence, and a new approach to life in low Earth orbit. Inside, scientists could study diseases in ways that aren't possible on Earth, grow plants in microgravity, develop new materials, and explore manufacturing techniques that rely on the unique conditions of space. Large viewing windows offer breathtaking views of Earth, while spacious crew quarters, modern laboratories, and intelligent onboard systems are designed to support months of continuous research. Outside, the station becomes a laboratory of its own. Powerful robotic systems will install and operate experiments exposed directly to the vacuum of space. External research platforms will allow scientists to observe our planet, test new technologies, expose advanced materials to the harsh space environment, and prepare the next generation of spacecraft for missions deeper into the solar system. Every part of the station has been designed with one purpose in mind: making research in space more capable, more accessible, and more efficient than ever before. This is Starlab. It is one of several commercial space stations now being developed to continue humanity's scientific presence in low Earth orbit after the International Space Station reaches the end of its operational life. For more than 25 years, the International Space Station has enabled thousands of scientific investigations while serving as humanity's only permanently inhabited laboratory beyond Earth. But maintaining such a vast orbital outpost has become increasingly expensive, and its retirement is now planned for around the end of this decade. Rather than building another government-owned station, NASA is encouraging commercial companies to provide the next generation of research platforms, allowing the agency to focus more of its resources on returning humans to the Moon and preparing for future missions beyond. To understand why Starlab exists and why this new generation of commercial space stations is becoming so important, we first need to understand the remarkable story of the International Space Station. Long before Starlab was conceived, the world came together to build something that had never been attempted before. At the end of the Cold War, former rivals chose cooperation over competition. The United States and Russia, joined by Canada, Japan, and the member nations of the European Space Agency, agreed to construct a permanently inhabited laboratory unlike anything humanity had ever built. The project would eventually become the International Space Station. Construction began on November 20, 1998, when Russia launched the Zarya functional cargo block. Although built with US funding, Zarya was constructed in Russia and provided the first electrical power, propulsion, and guidance systems for the future station. Just over 2 weeks later, Space Shuttle Endeavour lifted off on mission STS-88, carrying the Unity connecting module into orbit. During a series of spacewalks, astronauts joined the two spacecraft together, creating the first building blocks of what would become humanity's largest structure in space. But this was only the beginning. Over the next decade, dozens of missions delivered laboratories, solar arrays, truss structures, life support systems, docking ports, robotic equipment, and living quarters. Unlike Starlab's single-launch approach, the International Space Station had to be assembled piece by piece while traveling at nearly 28,000 kilometers per hour above Earth. Every new module expanded the station's capabilities. What emerged was far more than an engineering achievement. For more than 25 years, astronauts have lived and worked aboard the International Space Station without interruption. More than 280 people from over 20 countries have called it home, carrying out thousands of experiments in medicine, biology, physics, materials science, and human spaceflight. Yet the station was never designed to operate forever. Every day in orbit exposes it to radiation, extreme temperature swings, microscopic debris traveling at tremendous speeds, and the constant wear of keeping a complex habitat alive hundreds of kilometers above Earth. Maintaining the ISS has become increasingly expensive, and with retirement planned around 2030, the world faces a question it has never faced before. How do you replace one of the greatest engineering projects ever built? That question would inspire a new generation of commercial space stations, including Starlab. Building a space station is far too ambitious for any single company. That's why Starlab brings together an international team of aerospace leaders, each responsible for a different part of the project. Voyager Technologies leads the overall program, drawing on years of commercial spaceflight experience through its NanoRacks division, which has supported hundreds of research missions aboard the International Space Station and operates the Bishop Airlock. Airbus is developing Starlab's primary habitat, the large pressurized module where astronauts will live, work, and conduct scientific research. The company also built the Columbus Laboratory for the ISS and contributes decades of experience in human spaceflight. Robotics come from MDA Space, the Canadian company behind Canadarm, Canadarm2, and Dexter. Their next-generation robotic system will help inspect the station, install external experiments, and support maintenance in orbit. Mitsubishi Corporation is expanding Starlab's commercial and international reach, helping connect research organizations, government agencies, and industrial partners across Asia with the station's future capabilities. Other partners bring specialized expertise as well. Palantir is developing digital systems to help manage station operations and scientific data. Hilton is advising on crew accommodations, applying decades of hospitality experience to improve daily life for astronauts during long-duration missions. Together, these companies are combining decades of spaceflight experience into a single goal, not just building another spacecraft, but creating a laboratory designed for the next era of research in low Earth orbit. At first glance, Starlab is larger than most people imagine. The station measures approximately 17 meters in length and 7.7 meters in diameter. That makes it roughly as long as a humpback whale. To put that into another perspective, it's approximately the length of 3 Tesla Cybertrucks parked bumper to bumper, and about as tall as 6 Cybertrucks stacked one on top of another. But it's what's inside that makes Starlab truly different. The station is organized across multiple levels, each designed for a specific purpose. Dedicated areas house the station's critical systems, research laboratories, storage, exercise equipment, and private crew quarters, creating a layout that feels more like a purpose-built research facility than a collection of connected spacecraft modules. The interior has a clean, futuristic design. Large digital displays provide astronauts with mission data and station information, while the weightless environment allows every wall, ceiling, and floor to become part of the workspace. 2 large windows fill the habitat with natural light and offer spectacular views of Earth, giving the crew a constant connection to the planet below. To help make long-duration missions more comfortable, Hilton has worked with the Starlab team on the design of the crew accommodations and shared living spaces. At the heart of the station are 13 internal research platforms, capable of supporting around 130 mid-deck locker-sized experiments. Scientists will be able to investigate human health, grow plants in microgravity, study protein crystals, develop future medicines, and test advanced materials that behave differently in the absence of gravity. Each laboratory is equipped with power, cooling, high-speed data connections, and specialized research interfaces, allowing multiple experiments to run simultaneously while being monitored by researchers on Earth. Beyond the station's walls, external payload platforms expose experiments directly to the vacuum of space, where scientists can test new spacecraft materials, observe Earth, and evaluate technologies for future missions deeper into the solar system. Every section of Starlab has been carefully designed with one purpose in mind: to create a station where astronauts can live comfortably while giving scientists one of the most capable research laboratories ever placed into orbit. One feature you'll find on Starlab isn't new at all. It's called the Bishop Airlock, and it has already proven its value aboard the International Space Station. Developed by NanoRacks, now part of Voyager Technologies, Bishop became the first commercially owned and operated airlock ever installed on the ISS when it arrived in 2020. Since then, it has supported a growing number of commercial and scientific missions, giving researchers a dedicated way to move equipment and payloads between the station and the vacuum of space. Over the years, Bishop has been used to deploy small satellites, transfer scientific hardware, and support technology demonstrations that would have been difficult using the station's existing government-operated systems alone. It also gave commercial customers more direct access to the unique environment of space, opening the door for universities, private companies, and research organizations to carry out their own orbital missions. That experience is one of the reasons Voyager chose to carry the Bishop concept forward into Starlab. Rather than starting from a blank sheet of paper, the company is building on years of operational experience gained aboard the International Space Station, refining a system that has already demonstrated its reliability in orbit. It's a reminder that many of the technologies shaping the next generation of space stations have already been quietly proving themselves hundreds of kilometers above our heads. Behind every great space project are the people turning ambitious ideas into reality. Leading that vision is Dylan Taylor, Chairman and CEO of Voyager Technologies. A longtime advocate for commercial spaceflight, Taylor has helped position Voyager as one of the key companies developing the next generation of commercial space stations and expanding private industry beyond Earth. Working alongside him is Marshall Smith, Chief Executive Officer of Starlab. After more than 3 decades at NASA, where he contributed to major human spaceflight programs including Artemis, Gateway, and Ares 1 to 10, Smith now leads Starlab as it moves from design into development and ultimately flight. Serving on Starlab's board of directors is Jim Bridenstine, NASA's 13th administrator. During his leadership, NASA accelerated the Artemis program, expanded commercial partnerships in low Earth orbit, advanced the X-59 quiet supersonic aircraft, and guided the agency through the final preparations for the launch of the James Webb Space Telescope. Today, he brings that experience to one of the most ambitious commercial space projects ever undertaken. Together, they represent just a small part of the thousands of engineers, scientists, and technicians working to build what could become one of humanity's next great laboratories in space. Starlab is just one vision for the future of humanity in low Earth orbit. But it isn't the only one. As you can see, several remarkable space stations are already taking shape, each with its own unique design, technology, and approach to living and working in space. Right now, you're seeing Orbital Reef, a commercial space station being developed by Blue Origin and Sierra Space, another ambitious project that could help define the next era of space exploration. If you'd like to explore Orbital Reef in more detail, be sure to watch our full documentary next. Thank you for spending this time with us here on Wormhole to Cosmos. If you enjoyed this journey, we'd truly appreciate your support. Give this video a thumbs up, subscribe to the channel, and join us as we continue exploring the extraordinary engineering, science, and discoveries shaping humanity's future beyond Earth. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.